Alright, so here we are with our new chapter, chapter 5, section 1 here. And we're going to be solving some systems by graphing. Basically, a system just means that you're having two equations and they're kind of together. So it's kind of like two scenarios happening at once. So we're going to identify some solutions of linear equations in two variables, and then we're going to solve these systems by graphing. So here's kind of the idea behind a system. So again, it's a set of two or more linear equations. And so if you kind of take a look at this example here, we've got our first equation, which is given by this function, and then our second equation, which is given by this function. They have them both there in standard form. And then this right here, which is an interesting way of telling it, is called the solution. So our solution, or our answer, is going to be given as a coordinate point. Basically, it's just saying where do these two lines that you graphed meet. So down here, just a little bit more clarification. Solution of a system of linear equations is an ordered pair, so that's this guy right here, that satisfies each equation in the system. So it will be on this line and at the same time on that line. So, to find the solution of a system of linear equations, you need their point of intersection. So we kind of saw that on the previous page, and we also see it right here. Two linear lines meet only once, unless of course they're parallel, which we'll actually go over later. But in this set of examples for section 1 here, it's just always going to meet one point. That point is the solution. So we write a system like this, so we get to practice our little squiggly brackets here. And then we have our first equation, and a lot of times I will of course do it in one color so I can graph it in a color. And then we have our second linear equation, and then usually I graph it in whatever the other color is. So it looks like the point 2, 3 right here is where the two lines intersect, and it's the solution of both equations. For instance, if I put in an x of 2 in for this x or this x, I would get a y of 3 back out. And so 2, 3 is the solution of the system. So again, two lines graphed at the same time, that's our answer. So this first one here, we're supposed to tell whether the ordered pair is a solution to the given system. Turns out we don't actually have to graph it. We could take the time to graph this one, but in this one, all you actually need to do is plug it in and see if it works. So these ones are actually saying, here's our system. Is this the answer? And so of course you could graph them, but depending on what's going on there, I mean sometimes it's time consuming to be graphing all the time. So instead, all we're going to do is take this x and this y and plug them in over here for x and y and see if it works, see if you get 0. And then over here we'll plug in the x and the y again and see if it works or we get 13. So in the top equation we've got 2/5, but instead of an x we're going to have 5. And instead of a y, we're going to have 2. We're going to see if that equals 0. The other one, we have a 3, and instead of an x, we'll have a 5. And then instead of a y, we'll have a 2. And we'll see if that equals 13. So this first set here, 2/5 times 5, is actually 2. That's nice. So 2 minus 2, we're double checking, is that 0? And it turns out it is. 0 is 0, and so that one works. This next one here, we're doing 3 times 15, so that's 15. And then we want to solve 15 minus 2, is that 13? And it is. And so that one also works. So since both let's see, work out equally, 5, 2 is the solution. Alright, so Here's another one just like that. Normally when we have class, this is the one that I would pause for you to try on your own, given that we just did one very much like it. So the whole idea again is that this would be an x and a y, and you're plugging them in and see it if you get true statements. So go ahead and pause the video if you would like to actually solve that out before I do. Otherwise, we're going to just start plugging these in. So let's see, instead of an x, I'm going to have a -2 for this first equation, and then a 3 times a y, which is 2, and see if that equals 4. And then the second one, I'm going to have a negative, and this is very weird because you're putting a negative into a negative, but there we go. And then we're going to add a y of 2, and we're going to see if that equals 2. So again, the idea is that you would simplify, so we've got 3 times 2 in order of operations. We would do multiplication first. So we're going to take -2 and add it to 6 for 3 times 2. And we're just double checking that that works, and it turns out it does. And then we move on to the next one and we say, okay, well, so that one is -2, and so that's actually 2. We're going to add that to 2 and see if it becomes 2. It's a very odd thing to think about, because of course it's not. And so because the second equation is not equal, 4 does not equal 2, -2 is not a solution of the system. Now, of course, it is a solution of this equation, and that's perfectly acceptable, but it is not a solution of the system. So we just want to be clear that that's what we're looking for, and not just an equation. Alright, so the next ones we're going to solve by graphing, and again, you could have done the other ones by graphing as well, but again, graphing a ton is kind of hard. So in that case, the first one that we're going to graph here has a slope of 1 over 1, right next to the x, and an intercept of 0. So it meets at 0, 0, and then it's going to go up 1 over 1, and then of course down 1 over 1 as well to make that. When we do systems, it's actually best if you take the time to do every single point. Usually there's not as many as there are right now, but if you do every single point, because it will actually meet at exactly one of these points, and if you start to draw a line kind of curvy like I just did, you might not actually find that exact point. So the next one has a slope of -2 over 1, so down 2 over 1, and its intercept is -3. So it goes through at -3, but then goes down 2 over 1, down 2 over 1, so it's clearly not going to intersect there. But up 2 over 1, that's exactly where the other one exists. Up 2 over 1, up 2 over 1, and so we've already found that it's going to meet right there at that point where they both intersect. So at -1, -1. And so that's our solution, and it does say check your answer. And so there are multiple ways. Later on we'll talk about using the calculator, but right now you can of course plug that in and double check that that works. For instance, this first one here, if I plugged it into y equals x, yes, y does equal x. Also, if I take -2 and multiply it by the x, I get +2. And then if I subtract 3, I get -1. And so they do both work. So just double checking that your lines aren't going off in the wrong direction to make it seem like it's another solution. Alright. So the next one, again, if we were in class, I'd have you maybe try this one, but it does say graphing calculator example. So I'm not going to actually show you the graphing calculator at this point, but I am going to kind of double check that you would know how to put it in there, because I am on a different device here. So the first thing is that everything that you want to put into a graphing calculator needs to be in y equals mx plus 4 plus b format. So this one already is in y equals mx plus b format, so that's great, but this second one isn't. So we would have to take the time to rewrite this so that -2x moves over. which would leave us with y equals negative 2x plus 4. So you do need to take the time to write the 1 in y equals mx plus b format so that you can graph both of them. Then if we look at what you're doing here, and this is where you would write down these steps so you could do it on the graphing calculator later. So again, this one here, you would actually be typing in y equals negative 2x plus 4 instead of that one, because you can't type that into the calculator, because it's only a y equals. So how do you check with your graphing calculator? What you can do is enter the equation into y equals. So again, once you turn your calculator on, there's a y equals button at the top. Then you set your window, so you would want to press the bluish button at the top or around the screen there that says zoom, and you go down to number 6, because number 6 is a standard window, which is 10 by 10, just like this image is, this graph I've been presenting is a 10 by 10. Then you're going to find the intersection, so you can actually have the calculator figure out what that point is. And so you would go second button, because you're actually finding the trace key. So second trace, and that actually allows you to go down to number 5, which is the option of intersect. Then it'll ask you, it'll pop to this screen, and it will have this little piece here, and it'll say first curve, and it'll say second curve, and guess. And so all you really need to do is press enter, 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 because it'll only hop from the one equation you even have there. So enter, 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 and then it will automatically tell you what that point is down here. So it's pretty simple as long as everything is already written as mx plus b format. So that's really nice. So you could, for instance, take the one that we had before, this one, and you could have graphed it on the calculator, gone through each of these steps, and then it would have allowed you to notice that it was at negative 1, 1. Negative 1, negative 1 for the answer. So those are our notes, and during class we will, when we record the notes, I will do it with a calculator just so that you can double check that you understand that piece as we go through it. But otherwise, hopefully we can plug in our point and then also graph 2 lines by hand. And that is our solution of a system.